Alright, questions 29 through 44. Oops. There we go. 29 through 44. Number 29, you're given this box. It says, what is the intersection of plane CED and plane ABD? So CED is this front plane here. Okay, so it's like the front of the box. And then plane ABD, it would be the top of the box. So hopefully you guys can see that they intersect at this point, or at this line actually, right there. So planes intersect at lines. In this case, this is line CD. So the intersection of plane CED and ABD would be line CD. And it always helps to kind of shade in your boxes and see your planes. Number 30. For RST, list the sides in order from least to greatest. So hopefully you guys remember that the smallest side is always opposite the smallest angle, and the greatest side is always opposite the greatest angle. So first we need to find this missing angle here. So let's subtract from 180. So it'd be 180 minus 80, so 100 minus 70, so it's just 30 degrees. 30-degree angle. So I know that my smallest side is going to be across from the 30-degree angle. So my smallest side is going to be ST or TS. So I know it's going to be B or C. Now my next smallest side is going to be across from the next smallest angle, which is 70. So across from 70 is RS. And then across from 80 we should have RT. So our correct answer should be TS, RS or SR, and RT. So the correct answer is C. 31, similar question. So we need to list them in order again from the least to greatest. 59, 60, so this is a 61-degree angle. And we know that the smallest angle, or smallest side, is opposite the smallest angle. So B is the smallest side. And the next one from that would be C. And then the next biggest would be A. So we're looking, so we're looking for B is less than C is less than A. So B is less than C is less than A. So the correct answer is D. Number 32, give the measure of one angle, so we're only looking for one, of a regular decagon. So for all the angles of a decagon, we would be using this formula, decagon, so 10. So it'll be 10. But since we're only looking for one angle, we have to divide it by the number of angles it has, or the number of sides it has. So for decagon, we're going to be doing 10 minus 2 times 180, all over 10. 10 minus 2 is 8 times 180 divided by 10. 8 times 180, I believe that's going to be 1440. When you divide it by 10, bam, 144. So that gives us the measure of one angle. Okay. And this formula is in your reference sheet. Two adjectives for the triangle above. Remember, adjectives are words that describe things. So how can we describe this triangle above? Well, looking at its sides, I see none of them are equal. So a good word to describe it could be scalene. Alright, now if I look at its angles, I see that they're all acute. So I'm going to pick scalene acute. Number 34, two adjectives that describe this triangle. Well, now even though it doesn't say it, it looks like a right angle. So we're going to assume that it's a right angle. So I like B, and we can also say that it's isosceles because we have two congruent sides. So we're going to go with B, right isosceles. Number 35, give the sum of the angle measures of a convex octagon. Remember, convex is just everything that we've been dealing with in class. All the shapes that we've talked about have been convex. So the sum of the angle measures of an octagon. Well, an octagon has 8 sides. We're using this formula, by the way. 8 sides, so our n is 8 minus 2 times 180. So 6 times 180. And you should get 1080. An exterior angle of a regular polygon has a measure of 12 degrees. How many sides does that polygon have? Well, we know that all the exterior angles have a sum of 360. So we can take that 360 and divide it by that 12 degrees to find out how many sides it has. And I think I did this one earlier, and it should be 35. 360 divided by 12. Yeah. So this guy has 35 sides. Okay, regular hexagon, so we're talking 6 sides, has one side that is 12 centimeters. What is the perimeter? Well, the perimeter is the distance around it. Let's try to draw one. That's pretty darn good. It's regular, so all the sides are the same. And one side is 12, so all sides are 12. So to find the perimeter, we'll just take that 12 and multiply it by the number of sides. In this case, 6. So the perimeter equals 72 centimeters. Question 38 and 39. Okay. If Q is the midpoint of MK, so Q is the midpoint of MK, good stuff, and J is congruent to L, okay, good, then the triangles are congruent by which one of these postulates or theorems? So we also got to look at what else we know about these two triangles, and I know that I've got some vertical angles right there. So I would say that these two triangles are congruent by angle, angle, side. So remember, you got to go consecutively around the triangle. Angle, angle, side. And then which two triangles are congruent? Well, you could say MQJ, MQJ would be congruent to what matches up with M, K does. So K, what matches up with Q? Well, Q matches up with Q. And what matches up with J? L does. So KQL. Okay, more congruent triangles. RUS and TSU are congruent by, well, we know that R and T are congruent, and RSU and TUS are congruent. But we also know that this SU is shared between both the triangles. So that's also congruent. So we would have angle, angle, side. Cool, another one. And again, this middle side is shared by both these triangles. So they would have a side, an angle, and a side. Side, angle, side. So SAS. If triangle RUS and TSU are congruent, then which is not true? Well, is RS congruent to TU? RS, TU, yeah, that is true. Is angle RUS congruent to UST? UST. Well, yeah, they are, because U would be the vertex and S would be the vertex, and those are matching, so they'd be congruent. So that is all good in the hood. RU and TS. RU is the first two, TS is the first two, so that's good. How about US and TS? US and, hey, look, they don't match up. US is the last two and TS is the first two. So we would say D doesn't work. They're not in the right spots. Alright, number 43, true or false? A rectangle has all sides congruent. Well, that's not true because only the opposite sides are congruent. So they're not all congruent. It's false. A rectangle has perpendicular diagonals. Well, that's not true. That's a kite. It's got perpendicular diagonals. These are not quite perpendicular. A kite has all sides congruent. Well, it doesn't have to. Well, false. Usually these are congruent. A kite has perpendicular diagonals. There we go. Yeah, that one's true. Like the crossbars on a real kite. Finally, one that's true. A square has all sides congruent. Well, that's true. We all know that. A square has perpendicular diagonals. Well, guess what? Let's draw one. I won't be able to draw a perfect one, but it's pretty darn close. Look at that. Perpendicular diagonals. True story. A rhombus has all sides congruent. Well, that's true. Yay! A rhombus has perpendicular diagonals, and that's also true. That's where the square gets it from. A trapezoid has all sides congruent. Well, that's just silly. A trapezoid has perpendicular diagonals. Not necessarily. Alrighty, kicking butt. Sketch a kite. Okay. Ooh, that's ugly. Oh well, we'll do an upside down kite. Alright. Let's say that those sides are congruent, and let's give it some crossbars. Some diagonals. Now I know for sure that it's a kite. Use the tail. Sketch a rhombus that is not a square. Oh, this is going to be tough for me. Now let's make sure we know it's a rhombus. That's not perfect, but whatevs. So it's got all sides congruent, so we know it's a rhombus.